Good morning, friends. This is Madhira Srinivas, Associate Professor, Department of Computer Science and Engineering, SBIT College, Khammam. So, in the last two classes on structures, we have discussed some basic concepts about the structures. In the class 1, we have discussed the basic way of using structures in C program. In class 2, we have discussed some important programs using structures. Basic programs we have written. So it has given the exposure to you all about the using the structures in C programs. Now this is the lecture 3 on structures. So in lecture 3, we will discuss about few more concepts on structures. So for today's class, the concepts covered are operations on structures, array of structures, programs for practice. So these are the things that we will discuss in today's class. Operations on the structure. What type of operations are performed on the structures? So this we have to discuss. Basically, we can perform two operations on the structure. What are these two operations? First operation is copying the structure, and second operation is comparing two structures to know whether the structure variables are equal or not. Copying the structures. First operation is the copying the structures operation. What do you mean by copying the structures? Copying the structures means it is nothing but the content of one structure variable is copied into another structure variable. So this is called copying the structures. Again, I am repeating. Copying the structures means the content of one structure variable is copied into the another structure variable. For this, two structure variables must be of same data type. If two variables are of same data type, then only we can copy the content of one structure variable into the other. So how do we copy? So copying is very simple. Suppose I give you one example. If you are working with the primary data types, suppose if I declare two primary data variables as int x comma y, then after declaring x and y variables as integer data type, I can assign some value to the variable y. Suppose y is equal to 20, I have assigned. And suppose if I want to copy the value of variable y into the variable x, then simply I can write a statement like x is equal to y. When I write x is equal to y, what happens is compiler copies the value of the variable y into the variable x. So once this statement is executed, x equal to y statement is executed, variable x is having value 20 and variable y is also having 20. Why? The contents of variable y is copied into the variable x. After executing this statement, both x and y variables are holding the same value. Now here, variable x and y are of same data type. The same concept can be followed even for structures. So here I wrote one statement that if two structure variables are of same structure type, then the content of one variable can be copied directly like normal variables into another structure variable. I gave an example here. Struct book means here we have taken book structure. A book structure we have taken. Variables bk1 and another variable bk2. They are declared to store values of structure book type. bk1, bk2 here declared as structure variables. They can store the values of structure book type. Now here if bk1 is initialized with some values, bk1 is a structure variable of type book. So inside the bk1 structure variable, we are having many member fields like title of the book, author of the book, number of pages in the book, and price of the book. Already we discussed about book structure. So this inside this book structure we are having these 4 member fields. Assume that bk1 structure variable is initialized with some values. We have assumed that we have assigned some values to the member fields of bk1 structure variable. Now we would like to copy the contents of bk1 into the bk2 structure variable. So then simply like normal variable, just like I have given one example, x equal to y you wrote. Similarly we can write bk2 is equal to bk1. bk1 and bk2, since they are of same structure type variables, so therefore compiler automatically copies the contents of bk1 structure variable into the bk2. Means inside the bk1, whatever values are stored by the member fields of bk1 structure variables, all those values are also copied into the member fields of bk2 structure variables. Means what we have to understand here is, if 2 structure variables are of same type, directly we can use them like the normal variables, and you can copy the content of one structure variable into the another structure variable. Means you need not copy member field by member field. That is the importance of this statement. Structure variables, when they are of same data type, they can be copied directly by writing the statement structure variable 2 is equal to structure variable 1. So content of structure variable 1 is copied into the structure variable 2. For this we will see a sample program. We will take the same structure, book structure, with 4 member fields: title, author, pages, and price. Title is character data type, which is declared as array of character because a title of the textbook is having some sequence of characters. Similarly, author is also a string, author name, so it is also declared as sequence of characters, means array of characters. Pages, number of pages in the textbook is declared as integer. The price of the textbook is declared as float. Now we are going with the main program. So this is the definition of the structure, and all other parts of the program I am not discussing because already all these things are known to you. We have discussed in the previous 2 classes on structures. Now we are going with the main program. Inside the main program we have created 2 variables, structure variables, bk1 and bk2. And then what we did is we are initializing bk1 structure variable. bk1, inside the bk1 structure variable you are having 4 member fields: title of the book, author of the book, number of pages in the textbook, and then price of the textbook. First I am assigning a value to the member field title. So title is accessible by writing structure variable name followed by a dot followed by the member field name. Member field name is title. Since it is array of characters, we are using string copy function. Here we have given the title of the textbook as C programming. Textbook title is C programming. So this string we are copying into the member field title in the structure variable bk1. Similarly, the second member field, string copy function, here if you observe carefully some printing mistake is there. That is, string copy function usually written as strcpy. Here str is printed twice. You write only one time, strcpy. Then second statement, if you observe, author name is Balagurusamy. So this we have copied into the member field author inside the structure variable bk1. For this, because both are of array of characters, we have used string copy function. Since we are using string copy function, we have included string.h header file to our program. Whenever you are using string handling functions, it is mandatory to include string.h header file to our program. We have included string.h header file. Without including this string.h header file, if you are using any one of the string handling functions from string.h library, then automatically compiler will raise an error. So therefore, to avoid such kind of errors, we have to include string.h header file to our program. Then after two member fields, title and author, are initialized with the values, then you can initialize the third member field, pages. Here I wrote the number of pages as 256. 256 pages are there in the textbook. So therefore, to the pages field I have assigned value 256. So it is assigned to pages variable member field inside the bk1 structure variable. Similarly, the price of the textbook is mentioned as 273.5 rupees. That is assigned to price member field of bk1 structure variable. Now, what we do is, we will copy the contents of bk1 structure variable into the bk2 structure variable by writing bk2 equal to bk1. So inside the bk1, all member fields of the structure variables have been initialized. All these values are automatically copied into the member fields of bk2 structure variable. Let us see whether these values are successfully copied into the bk2 structure variable or not by printing the contents of bk2 structure variable. So here I wrote statements, output statements. The details of the textbook 2 are, I am printing the title of the textbook, author of the textbook, number of pages, and the price of the textbook. And all these variables you carefully observe here. bk2 dot title means the title member field of bk2 structure variable. Author member field of bk2 structure variable. Pages member field of bk2 structure variable. Price member field of bk2. All here are, we are referring bk2 structure variable, but directly we have not assigned any value to bk2 structure variable. bk2 structure variable is getting values from bk1 structure variable. Values from bk1 are copied into bk2 structure variable. We are displaying this. Whatever values you have assigned to the member fields of bk1 structure variables, they are successfully, they will be displayed on the screen. So from this we can understand that structure variables, if they are of same structure data type, then they can be directly assigned. So that is the main motto of this program. This is about the first operation on structures, copying the structures. Then we will go to next operation on the structures. What is the next operation on the structure? The next operation is comparing two structure variables. If you want to compare two structure variables to know whether two structure variables are equal or not equal, then we cannot compare just like normal primary data type variables. Suppose if you are having two primary data type variables x and y of integer type, then we can write the statement to know whether x value is equal to y or not. We can write the statement if x is equal to y. Like that we will write. Means if x value is equal to y, then it returns a value 1. If x value is not equal to y, it returns a value 0 in the if conditional statement. But here, suppose we are declaring two structure variables, bk1 and bk2. These are the two structure variables. They are of type book structure. Means bk1 and bk2 are the structure variables of same structure type. Even though they are same structure type variables, we cannot compare them like this. If bk2 is equal to bk1 or not, this statement is wrong. You cannot compare two structure variables directly. Normally, to compare two variables, we use relational operator. We have different relational operator: equal to, less than or equal to, greater than or equal to, not equal to. All these are the structure variables. So these, all these are relational operators. Relational operators are used to comparing the two variables to know whether one variable value is equal to other variable or not, or whether one variable value is not equal to other variable or not, whether one variable value is less than or equal to other variable or not. To know like this, you can use the relational operators. So relational operators cannot be used directly on the structure variables. If you want to compare two structure variables, what you have to do is you have to compare them member field by member field. So that is the important thing that you have to note. If two structure variables are to be compared, they need to be compared member by member. If all member fields of the structure are holding same values, then only we can say that those two structure variables are of equal. Otherwise, we say that if any member field is not having equal values, then we can say that those two structure variables are not same. Here again, to demonstrate this simple example I have mentioned here, bk1, bk2 are two structure variables of type book structure. Assume that we would like to know whether bk1 structure variable is equal to bk2 structure variable or not. For that, we are comparing them member field by member field. Both bk1, bk2 structure variables contains 4 member fields: title, author, pages, price. So these member fields are compared member field by member field. See, bk1 title, bk2 title, we are comparing them using string compare function because they are array of character. Whether they are, if they are equal, its value is a string compare function returns a value 0. Similarly, bk1 structure variable author field is compared with bk2 structure variable author. If both authors are same, then string compare function returns a value 0. And then the number of pages in bk1 structure variable, number of pages in bk2 structure variable, both are compared, whether to know whether they are equal or not. Similarly, the prices, again bk1, bk2 are compared. If all these member fields, 4 member fields in both structures are same, then entire expression will be true. When the expression is true, because all this expression is totally, we are having 4 sub expression. This is sub expression 1, sub expression 2, sub expression 3, sub expression 4. All these sub expression, 4 sub expressions, if they are true, the entire value of the expression will be true. If entire value of the expression is true, then we will getting the message 2 books are same. Else, if any member field is not having same values, the entire value of the expression becomes false. If it is false, then it prints a message saying that 2 books are not equal. And to demonstrate this same logic, we can keep inside the C program. Whatever program we discussed previously, same program we will write here to compare 2 structure variables. See here, we have declared a structure called book. Inside book, 4 member fields as usual: title of the book, author of the book, number of pages in that textbook, and the price of the textbook. And inside the main program, we declared 2 structure variables, bk1 and bk2. Now, as usual in the previous program, we have initialized the member fields of bk1 structure variable. Title as initialized with C programming, author is initialized with a value Balagurusamy, and the pages are initialized with a value 256, and the price is initialized with a value 273.5 rupees. Now we are assigning the content of bk1 to bk2. So automatically all the member fields of bk1 structure variable values are copied into the member fields of BK2 structure variable. Means BK1 structure variable and BK1 member fields and BK2 structure variable member fields will contain same values. That is known to us. Now we are printing the contents of book 2 as usual in the previous program. The next thing what we are doing is we are comparing the contents of member fields of both BK1 structure variable and BK2 structure variable. Whatever statements we have written previously, same logical statement with 4 sub-expressions we are writing here. If all these fields are equal, all these fields are equal, then entire expression becomes true. If entire expression becomes true, then it prints a message that 2 books are same. If any member field differs with the value of the corresponding member field in the structure variable, then it prints a message that 2 textbooks are not equal. Since BK1 content we have copied into BK2, then definitely here we know that 2 structure variables values are equal. So therefore definitely we will get a output from this program as 2 textbooks are same. So that is the output we will get from this program. Like that you can, if you want to compare 2 structure variables, what you have to do is you have to compare them member field by member field. If all member fields of the structure variables containing the same value, then we say that the structure variables are same. If any member field is not having equal value with its corresponding member field in the another structure variable, then we say that those 2 structure variables are not same. This is the conclusion that we can give. So these are the 2 basic operations that we normally perform on structures. First basic operation is copying the structure. Second basic operation is comparing the 2 structures. This is about the operations on the structures. Next we will go with the second topic called array of structures. What do you mean by array of structures? So till now we have used variables of primary data types, and then we have used arrays, and then we have used structures. Primary data type variables, as you know, they can hold only one value at a time. But when we want to deal with a group of values of same data type, then instead of using primary data type variables, we are going with the arrays. Arrays can be used to deal with the values of same data type. And then when you want to deal with a group of elements, logically related elements with different data types, then we are going with structures. Now here the problem is a structure is packing the logically related data items into one unit called structure. A structure variable, one structure variable can hold the details of only one item at a time. Suppose we have discussed a few examples. If you want to store marks details of a student in a class, normally every student is associated with 6 subjects in a class. To store the marks scored by the student in 6 subjects, along with these marks, we would like to store student name, student hall ticket number, student total marks, and student percentage. We are packing all these variables into one unit and we are calling it as a student structure. But when you declare a variables of this student structure, one student variable can hold information about only one student. Suppose if you want to store the marks of 10 students in the class, then you need to declare 10 structure variables. Up to 10 students it is okay. But if you want to store the marks score details of 60 students of a class, can you declare 60 structure variables? As the number of students are increasing, the number of structure variables are also need to be declared in the program. As more number of students are there, more number of structure variables need to be declared. Again, when the structure variables are more, it is very difficult to you to manage the program. To overcome this drawback, fortunately C language provided a solution that you can declare each element of an array. You can take the help of array and declare every element of the array as a structure variable which can store one student information. Means if you declare an array element as a structure, then it is called array of structures, because every element of the array is structure element. So you are having structures in the array. Every element of the array is considered as a structure. So each array element stores one student information. If you wanted to store 60 students marks scores of a class, then you need to declare an array with a size of 60 elements. Each element of the array will hold one student information. See how they can be defined. An array of structure means what? One structure variable holds only one entity details, such as a book, student, employee, item. All this we have discussed. And now, see, to hold many similar entities details, we need more structure variables, but it makes program very complex and difficult to understand. So the solution is, we use structures as an array elements. If every element of an array is a structure variable, then it is called array of structures. Array of structures are widely used to store the details of a group of entities of similar type. Now see how to declare this array of structures. The syntax to be followed to declare an array of structures is, keyword we have to use struct, then followed by the structure name, then array name, followed by size of the array. Example is struct student std60. Now std60, so it is an array. Std is declared as an array with a capacity of 60 elements. With a capacity of 60 elements. Each element is of type student structure. Student structure. So each element contains member fields related to the student structure. So std60 is an array with a capacity of 60 elements. Means you are having std0 index number 0 to up to std of index number 59. 0 to index number 0 to index number 59. Total 60 elements. Std of 0 is one structure element. Std of 1 is another student structure variable. Std2 is another student structure variable. Std3, Std4, like that up to Std59. They are the student structure variables. Each structure variable can hold one student information. Then how do you access a member field that is available inside std0, std1? So each of these are student structure variables. Each variable contains all these member fields of the student structure. How do we link them, these member fields? Member fields are linked with their structure variables through a dot operator. std of 0 dot ht number, student hall ticket number. That will give the first student hall ticket number, like that. So here all these elements are stored in the memory like this. This is the memory allocated to the array of structure variables. std0 of ht number, std0 of name, std0 of s1, std0 of s2, std0 of s3, std0 of s4, std0 of s5, all these member fields up to std0 of total, std0 of percentage, then std0 of up to std0 of percentage. From here to here, all these are related to the std0 student structure variable member fields. And then once student structure is over, then second student structure variable std1 is starting from here. So like that it is also having all the member fields up to here. Once std1 is over, then the space for the member fields of std2 structure variable is allocated. Then once std2 is over, then the space for the member fields of std3 structure variable is allocated. Like that it goes on up to std of 59 student member fields. Like that, the member fields are stored in the computer memory. Then to demonstrate this, again we will go with a program. So where we use same student structure that will store student hall ticket number, name, marks scored in 6 subjects, and from there we will calculate total marks scored by the student and then percentage of the student. And these details we will store for n students. N students details we will store. And we will calculate for each student total marks and percentage. And display all the student details of the class on the screen in a tabular format. Like your results are displayed on the notice board. Similarly, we have to display the marks scores of each student in the 6 subjects along with the total marks and the percentage of the student. Each row will give the details of one student. So each row is giving the details of one student. You are having n rows to know the details of n student. Now the program is, we are declaring the student structure, struct student, hall ticket number, name of the student, array of characters it is defined, and marks scores in 6 subjects. All marks we are assuming that they are integer type values, and then from once these values are read from the user, from those individual scores of the subjects, we will calculate the total marks of the student, and once total is obtained, you know how to calculate the percentage. Already this program for one student we have written, and it was thoroughly discussed in lecture 2 on structures. Same program we are writing here with a little difference. Once structure definition is over, then we are going with a main program. Inside the main program we are declaring an array of structures. STD of 100 means here STD is a array of structures. STD is an array declared with a storage capacity of 100 elements, and each element is a structure element. Which type of structure? Student structure element that we have declared like this. And we have declared 2 integer variables I and n. I is used as a loop control variable and n is used to hold the number of students. How many students are there? For all that students we have to read the details from the user for n students, and then we have to calculate for each student the percentage, and then we have to display all that student details in a tabular format. Now see how it is done. We are trying to read the values from the user. We are asking the user to enter how many number of students are there. Suppose user gives a value as 30, n value becomes 30, and 30 student details first we have to read. 30 student subject marks scores we have to read, and then we have to store them in the array of structures. So reading student details, see, reading student details at this percent D, I value is printed, this value I plus 1. Initially I is starting with 0. It will go up to I is less than n. N value, suppose if it is 30 students are there, I will change from 0 to up to 29. 0 to 29 means total 30 students details. So when I value equal to 0, here at this percentile D, it prints I plus 1 value. I value is 0 plus 1 means 1. So in the output you will get this string as like this, reading student 1 details, and you are asking enter the hall ticket number, name of the student in a row. So for first student you are entering his hall ticket number and his name. Hall ticket number is stored in std of 0. I value is initially 0. Std of 0 dot hall ticket number. Std of 0 means first student details, his hall ticket number. Std of 0 dot name. So 0 dot name means first student name. Then you are asking the user to enter the scores in 6 subjects of the student. So 6 percentile Ds we are using, and they are storing in std 0.s1, std 0.s2, std 0.s3. So like that, std 0, std 0.s4, std 0.s5, std 0.s6 in all such a variable. Once std 0 values are read, then I value is incremented by 1, I value becomes 1, then condition becomes 1 is less than 29 is true, then here it prints reading student 2 details, I plus 1 means I value is present 1 plus 1 2, so value 2 is printed, means you on the screen you will see a message that reading student 2 details, means you are asking the user to enter second student details, his hall ticket number, name and his marks. So once this is read and stored, then I value becomes, previously it is 1, now it becomes 2. 2 is less than, again n value is 30. 2 is less than 30. So here it will print a reading student percentage. 2 plus 1 means 3. Third student detail. Like that, student 1, student 2, student 3. When I value equal to 29, you are reading, it prints a message as 29 plus 1 means 30th student details, last student. All that will be read and they are stored in the std array. std 0 to up to std 29. 0 to 29 means total 30 student detail. std array is declared to have a storage capacity of 100 students. 100 student details it can store because it is declared with 100 elements. Each element can store 1 student details. 100 elements means 100 students details you can store, like that. You are reading all n students. N value we are assuming here as 30. So all 30 student details you are reading from the user. Then you have to calculate total marks and percentage for each student. And then you have to display them on the screen. So calculating total marks and percentage. So you are adding, when I equal to 0, for first student, total marks and percentage is calculated. std 0 of total equal to std 0 of s1 to up to std 0 of s6. All 6 subjects marks you are combining and then that value you are storing in std 0 total variable. Once total is obtained, then you are calculating percentage as usual. Here since integer division is there, temporarily the numerator is converted into float variable temporarily. So this is called typecasting. Already in that program, in lecture 2 of same program of the student we discussed. So that student percentage is stored in std of 0. Once std 0 is over, I value is incremented, I value becomes 1. 1 is less than 30 is true. Second student marks and percentage is calculated. Then I value becomes 2. 2 is less than 30. So third student I value equal to 2 means third student total marks and percentage is calculated. Like that, I equal to 3, I equal to 4, I equal to 4 up to I is I value is less than 30 means I value is less than 30 means up to I value is 29. This loop is going to be repeated. I equal to 0 to I equal to 29. This loop is executed. When I value becomes 30, 30 is less than 30, stops. So all 30 students total marks and the percentage is calculated. Now after calculating all the student total marks and percentage, we are going to display each student details in a tabular format. For that we wrote here the student details. The student details are printf, we are keeping a line, and then tabular header we wrote here first student serial number, hall ticket number of the student, name of the student, then marks scores in 6 subjects, followed by total marks of the student, then followed by the percentage of the student. So for I equal to 0, I is less than n, I plus plus. So simply you are displaying using printf statement first student serial number I plus 1 and then student hall ticket number std of I dot hall ticket number, then student name std of I dot name, and then marks scores in 6 subjects S1 to S6 for std of I, and then total marks and then percentage. So one after the other from I value equal to 0 to up to I value is 29. This loop is going to be executed and every student details is printed in a separate line. On a separate line they are displayed. So to display each student details on a separate line, we have used \n means new line character. Every student details is displayed on a fresh line, new line. For that we have used \n character. Once this is over, all student details are over, then what we have to do is we have to close the program. We are printing a line again. Once 30 students details are over, a line is printed there, and then it prints a message that program is over. Then the program is closed. This is how it is done. Next, so this is about array of structures. Array of structures are used to store a group of entities details. Each entity is a structure element. So group of structures. If you want to store, then we can go with the array of structures. That is the important concept. Then based on these two concepts, I give you few assignment programs for practice at your home. First, these two programs, three programs we have discussed in this class. One is how to copy the structure variables, and then how to compare two structure variables, and then how to use array of structures. Array of structures concept is very, very important for us. So I give few programs for practice on arrays of structures. So this is the first program that stores the details of an item with item number, item name, quantity and price. What you have to do is read values for these 4 member fields for n items from the user and display all the n item details on the screen in a tabular format. Like we have displayed student details, you are asked to display the details of an item in the supermarket. That is your first program. This program should be written again using array of structures. Then second program is again using array of structures. Here we are going with an employee details. Employee is associated with employee number, employee name, basic salary, DA, HRA, CA. All these three are allowances. And then total salary. Once these components are given, basic salary, DA, HRA, TA, total salary you can calculate. The summation of basic salary plus DA plus HRA plus CA is nothing but total salary of the employee. So what you have to do is here you have to read the details of n employees and then store n employee details in the array of structures. Then for each employee calculate the total salary and display n employees details on the screen in a tabular format. In a tabular format, how do you display? First serial number, then employee code or employee number, and then name of the employee, then basic salary of the employee, then followed by DA, HRA, CA, and then last column is total salary of the employee. Each row gives details about one employee salary. Next, third program is also using array of structures. What is that? Here you are asked to store the details about the textbooks for n textbooks in a library. So each textbook is having member fields. They are related with title of the textbook, author of the textbook, the number of pages in the textbook, and then price of the textbook. So n textbook details you have to read from the user and display them in a suitable tabular format on the screen. Like serial number, textbook title, textbook author, and fourth column is textbook number of pages. Fifth column is the price of the textbook. Each row talks about one particular textbook. Like that for n textbooks, you have to write the program using array of structures. That is what you have to do. Next, these programs you have to practice. Try to develop these programs on your own so that you will be getting confidence. You may be getting few errors when you write your program and submit it for compilation to the compiler. So don't worry about the errors. When you are trying to rectify your errors, you will learn more. Because once you rectify one error, you are coming to know where you are doing a mistake. When you are writing next program, you are not going to do the same mistake. You will be taking a lot of care. So therefore, from each mistake you are going to learn. If you are getting more mistakes in the program, you are going to learn more. As you are going on writing the programs, the number of mistakes in your program automatically they reduce. Means at some point of time when you write a program, you will write a program without any mistakes. If you submit that program to the compiler directly accepts your program. And it is not going to raise any errors in your program. means you are now the perfect C programmer. So perfection will be obtained with a lot of practice. Perfection will not come just like that. If you are going on practicing, if you are going on doing programming on the computer, if you are executing many programs on the computer, you will be getting perfection. Important questions related to these topics. First question is, discuss about how to compare two structure variables. We have discussed how two structure variables are compared. We have discussed. Second question is, write a short notes on copying the structure variables. How the content of one structure variable is copied into another structure variable. This also we have discussed. Then third question is, explain about array of structures with a suitable example. So this also we have discussed with a suitable program. So write the answers for these three questions. First two questions are short answer questions. Third question is big question. So for every question, you try to write one example program so that the examiner will get a lot of satisfaction with your answer and he will award maximum marks to your answer. While you are writing the program, don't forget to use indentation. Indentation is very important, because if you are writing program using indentation, the person who is evaluating your paper, they will get a lot of impression about your program and they can easily understand your program. So that is what you have to follow, the indentation. And then these answers, because these are the assignment questions, very simple. If you spend 1 hour time, you can write the assignment for this. So listen to this lecture carefully, take the notes while you are listening to the lecture, and then write the same answers, whatever is discussed in this class. Keep it in your own sentences and try to develop the answers for these questions and submit the answers for these questions by tomorrow afternoon. Okay, if you have any doubts, so you know my contact number 9848919656. I will be available to you between 9:30 a.m. and 5 p.m. daily on working days. Okay, thank you a lot for your patience. Thank you all.